Hi. Good evening, it's Ms. Zorn again. This is your second instructional video. I hope you had a good day today, and I hope that you have a great long weekend coming up. Okay, let's get started. We're on 1.4, day 1, and this is about functions. You're going to learn how to use function notation and how to evaluate functions and find their domain and range. Let's start with what a relation is. A relation is a set of ordered pairs. A domain of a relation is the x coordinates. And if it's a function, it's also the independent the independent variable. The range of a relation is the y coordinates. And if it's a function, then the range are the dependent variable. Okay, we've talked about a relation, we've talked about the domain and the range, and mentioned that if the domain in a function, the domain and the range are the independent and dependent variables. Let's identify what a function is versus a relation. A function is a relation where each domain corresponds to one and only one range. In short, when you see a list or ordered pair, it is where the x values do not repeat. There's not the same x value for two different range numbers or two different y values. All right, let's take a look at a couple of examples. What if I give you a set of ordered pairs? 1, 3, -5, 4, and 7, 3. All right, let's list the domain. The domain would be the x values. So in this case, that would be 1, -5, and 7. You can put them in order from least to greatest if you want, but I'm fine with just the order in which they appear in your set. The range. Our range is 3, 4, and 3, but when you have a number repeated, you only list it once. So that would be 3 and 4. All right, let's talk about whether this set or this relation is a function or not. The domain values do not repeat. There is not the same value more than once. So in our set of numbers, the domain numbers do not repeat. So therefore, this is a function. Okay. All right, let's keep moving. Let's talk about which of the following equations represent y as a function of x. Y is a function of x. Let's take a look at two different examples. Here's example A. In example A, we have 2x squared plus y plus 1 equals 0. To find out if y if the equation represents y as a function of x, you need to solve for y. So we would move the 2x and the 1 over to the right, and you would end up with y equals -2x squared minus 1. All right, let's just take a look at a t-table real quick at some values if we plugged into this equation. If we chose x to be 0, 0 squared is 0, And so 0 minus 1 would be negative 1. If we chose our x value to be 1, 1 squared is 1 times negative 2 would be minus 1, but would be negative 3. And if we chose our x value to be negative 1, negative 1 squared is positive 1, therefore we have negative 2 minus 1, again negative 3. You know this to be a quadratic. And so our graph would look something like this. We'd be at 0, negative 1. Oops. And we would be at 1, negative 3. And we would be at negative 1, negative 3. And we would have a sad face. Ooh, I didn't draw that very good. Sad face parabola. If you think about a vertical line test, and you drew that vertical line through, and you moved from left to right with your vertical line, there would only be one point under the line at each time. Therefore, this would be a function. So this is a function. Okay? All right, let's look at example B. Example B is y squared equals 6 minus x. Okay, once again, let's solve for y. I would need to take the square root of both sides. So I would have y equals, because I took the square root, I'd add a plus or minus in front. Okay, how do you know if it's a plus, or you add a plus or minus in front, or you have that in front of it? There's a little simple way I know, and I'm going to tell you on Monday. So one of the things I want you to do is ask me on Monday. Now, if you've had me in class before, you already know my little thing to remember how when you put a plus or minus in front of a square root. So if so, and you remember, then share with your group. If not, I'll tell everybody on Monday, so don't forget to ask me. All right, so we've solved for y. Notice this time if we make a t-table, what happens? If I choose 0, well, let's choose 6. If I choose 6, then I would get 0 underneath the radical, and I would just have 0. But what if I chose 2? If I put 2 underneath here, I would get 4, and the square root of 4 is 2. But it would be plus 2, or positive 2, and it would be also 2 would give me negative 2. And actually I could map that. We talked about that earlier. So actually I could map that. Let's erase this 2, and let's go back to our pen. And that would mean you could have 2, 2, or you could have 2, negative 2. Therefore, your ordered pair would be 6, 0. These are just some of the ordered pairs. 2, 2, and 2, negative 2. Notice all of a sudden, two of the domain values repeat themselves. So, sorry about that. So this is not a function. Okay, this is not a function. All right, so don't forget on Monday, I have an easy way for you to remember when you put plus or minus in front of a square root. Let's keep moving. All right, the next thing we're going to talk about is function notation. This should have said notation. Function notation. The function notation is a way we name the function. It's used to name the function. And you've seen it before. It's f of x. Sometimes it can be other things, but that's generally what it is. Since y is a function of x, since y is a function of x, then that's why we can replace y can now equal the name of the function f of x. That's a very important concept. Okay, so y is equal to f of x. And f is the name of the function. You could also name it v of x or c of x, use your own initial. F is not a variable. It is it's a letter that represents the name of the function. All right, let's take an example and evaluate some functions. We're going to evaluate the following function. Oops. We're going to evaluate f of x is equal to x squared minus 4x. We're going to evaluate it at f of 3. So that just means the x values are now 3. So you're going to plug it in. You're going to have 3 squared minus, I'm going to put that in parentheses, 3 squared minus 4 times 3. 3 squared would be 9. 4 times 3 is 12. 9 minus 12, that would give you negative 3. And that would be your answer. All right, let's evaluate for f of a. We'll get a little trickier. Now we're using letters. Okay, you still substitute a now in for the x values. So you would have a, squared minus 4 times a. That would just equal a squared minus 4a. And that would be your answer. All right, let's get a little more precalish. You're going to have f of x plus h. All right, now x plus h has to replace your x's. So we're going to have a parentheses, x plus h squared, and then we're going to have minus 4 times x plus h. Remind me on Monday again to tell you the shortcut for binomial squares. Once again, if you had me in class last year, you can share that information with your group. Please realize that this really means x plus h times x plus h. Once I FOIL that together, I would end up with x squared plus 2xh plus h squared. I would distribute the 4 and I would get minus 4x and minus 4h. And this would be my answer. Don't forget to ask me about the shortcut. All right, on to the last thought for the day. All right, for example 4, we have a little bit of a unique type of function. You saw this function maybe in Algebra 2. I want to talk about it. We're going to use it a lot in Precal. So f of x equals, and there's this big function bar, and we're going to say x plus 1, comma, if x is greater than or equal to 0. And it equals negative x if x is less than 0. This is called a piecewise function. Piecewise. It's different pieces of equations all in one function. So it looks like little parts of things. We're going to talk more about this later in the year. Let's evaluate if we have f of 2. All right, let's think about this. 2 is greater than or equal to 0. Therefore, we would plug 2 into the top equation. So it would be 2 plus 1 or 3 would be your answer. Another one would be f of negative 5. And in this case, negative 5 is less than 0. Therefore, we would have to use the second equation in our function. And we would have negative 5, and it's negative 5. So it's a negative, and then the x is negative 5 in this case. Therefore, that would be a positive 5. And that would be the answer when we evaluated in this piecewise function. Okay, I hope you have a good evening. I hope you have a fabulous long weekend. Please don't you can have a good long weekend and go to the website on Monday for additional information. The video will be downloaded sometime on Monday, and I will see you then. By the way, go Bearcats and beat Katie. Good night.